All right, as we get started today, I told you you got a quiz coming up here in just a moment. I want you to practice one graph very quickly. You will be instructed on the quiz to graph using the intercept method. What's an intercept again, Gavin? Noah, help him. What's an intercept?
It's like a point with two lines coming together something.
No, Brecken?
Where the line meets the axis.
Good, it's where a line crosses, or in general, where a graph crosses an axis. I mean, as you get further on in math, you'll work goofy graphs like this, like just crazy shapes. They're going to have multiple intercepts, right? Graphs like that where you'll have multiple y-intercepts, multiple... Well, for us, we're only graphing what kind of equations, class? Linear equations. So the graphs are always just going to be straight lines. So for our purposes, you're going to just have the one x-intercept and the one y-intercept. Again, an intercept where it crosses the axis. And the key to intercepts, class, is that where there is an intercept, one of the values, either abscissa or ordinate, is going to be 0, right? So if it's the x-intercept you're finding, the y value, the ordinate is 0. And if it's a y-intercept you're finding, the x value, or the abscissa, is 0. So I want you to graph this equation on your own graph paper. Negative 3x is equal to 9 positive 2y. Go ahead and use the intercept method to graph that equation. I didn't see it coming, I just saw it. Pastor Adam? That's Mr. McDonald. He's teaching 4th grade.
Oh.
I'm sure it's only till a real sub gets in there. To find the x-intercept, what do I need to do, Maddie? Put 0 in for the y. So we put it here as the y value, but we also put it in for the y, and what happens to the entire term, class? Just cancels out. So I'm left with what for my x value, Maddie? Negative 3. And then for the y-intercept, Gavin, what do I need to do? X is 0, right? So plug a 0 in here and also put a 0 here, which makes the whole term drop out. Now, here it's going to take 2 steps. What do I need to do first, Gavin?
9 over.
Okay, 9 over as a? Negative. Get negative 9 equals 2y. So what is y then?
Negative 9 over 2.
Good, negative 9 halves. Now, that's a fine thing to write here, but as far as graphing it, negative 9 halves, class, what is that? negative 4.5 or negative 4.5. So as we graph here, a couple of negative intercepts, a negative 3 on the x-axis, a negative 4.5. So down below the negative 4 on the y-axis, and should have drawn a line connecting those dots that looks like this. And how many had this line on your Cartesian plane? Questions? You forgot to move it over as a negative? So you have the positive 4.5, okay. Questions, comments? All right, yesterday we began talking about how this line has a certain slant to it, or class a certain slope to it, right? And we said slope is defined as what over what? Rise over run. And so we said that this line has a certain amount of rise, and then it has a certain amount of run. Now, because it rises and runs to the left or runs backward, we would say this has what kind of slope, class? Downward. Well, it appears to be going downward, that's true, but we would say the slope is negative. A line that goes downward has negative slope because it rises and runs negatively. A line, however, that were to go something like this would clearly have positive slope because it rises and runs to the right or runs positively. A perfectly vertical line would have, as you plunge to your death, you're not thinking, hey, there wasn't any slope at all. Undefined is the word. Undefined, infinite is a way of thinking of an undefined slope, whereas a horizontal line, that truly has no slope, right? It's not like, for instance, okay, cross country. My last ever cross country race was in Tallahassee. Most of Florida's flat, Tallahassee's not. So the race began with an uphill, and then at the very end of the race, you hit that same uphill again. And the first uphill I did okay, but after 3 miles, and I played just like pickup soccer the weekend before, and I didn't stretch first, so my muscles had been sore all week. At the end of a 3-mile race, I was practically walking up that hill. It was embarrassing. I'm a captain of the team. I'm one of the top runners in the region, and I'm practically walking up this hill. It was awful. Well, you have an excuse kind of there, right? Track and field, perfectly level track. You ain't got it. Oh, it was the slope coach. It got me. There is no slope. It's level, right? Okay, this is track and field. This is Tallahassee. Almost actually. Anyway, it was pretty bad. But anyway, or maybe I'm just making excuses. But anyway, yeah, the 4 different kinds of slope there. And we say slope is rise over run. What's that formula we would use to find slope? And what letter do we use for slope? And what's the formula to find slope? There we go, rise over run, a vertical change, a change in the y, over run, a change in the x. And we were using this formula as you did the homework, page 110 now in your textbooks. You did review 1 through 6. Page 110, review numbers 1 through 6, what you did for homework. Let's go and take a look at the answers there and see how we did in finding the slopes of these lines. In addition, you were supposed to specify whether if you had drawn the line, which we weren't because we're lazy, would the line go upward, downward, horizontal, or vertical based on what we got for the various slopes here. Number 1, given a point, -4, -3, given a point, -6, 2, what was the slope of the line, Maddie? I'm sorry? Ooh, math is just a little bit off there. Brecken? It should have been -5/2. Either way, the negative indicates, class, the line is going to slope downward, right? Negative slope goes downward. Maddie, be careful here. What was your y to, looking at your work? Oh. You put a -6 in this first spot? Yeah, that's an x value for one thing. Now I'm really confused how you got what you got. Now that I'm really puzzled. But yeah, so it shouldn't have started with a -6. Should have started with either a 2 or a -3, right? So let's just say we started with the 2. Then we'd have to subtract a -3, which is going to end up producing a positive right here. If we start with the 2, we have to start with the -6 minus the -4. Again, add the inverse to get the positive, and that's where we should have gotten a 5 over -2, or slide the negative out front, -5/2. For redemption, Maddie, number 2, what did you get for the slope? Negative 2/3. And again, that negative tells me that the slant is going to go downward because we have negative slope. Number 3, Noah.
Positive 4 over 1.
Good, positive 4 over 1, or you could just say 4, which clearly is going to slant upward with that positive slope. You were not here yesterday, Gavin. Did you take the time to do number 4? All right, what did you get for number 4?
Probably wrong, but I got negative 1.4 over 0.7.
Yeah, it is a little bit off. Let's go and take a look at it and see if we can figure out what we got here. As we've plugged in the slope, again, we need a y2 minus y1. So pick a y value to start. 0.5 minus the other y value.
Negative 1.9.
And again, because we've got back-to-back negatives, that produces a, so it's really 0.5 plus 1.9, which would be 2.4. All right, and then let's look at the x values. Since you started with 0.5, you have to start with 1.5 minus 2.3. Now, again, you're subtracting, keeping the sign of the greater, so we've got a negative 2.3, a positive 1.5 should give us, let me write it this way. 13 minus 5 equals, class, 8. So yeah, so we've gotten a negative 0.8 as we keep the sign of the greater. And in order to do this division, of course, we have to clear the decimals out. So move the decimals over 1 place each to get 24 over negative 8. Gavin, it should have come to a nice, easy answer.
Negative 24 over 8.
Which reduces down to, remember the fraction bar means division.
3 over 3.
Right, negative 3, I think is what you meant to say, right? Negative 3 should have been our answer there as we have a downward slope. A little harder with the decimals. How many got this, though? You managed to brave the decimals and get it? All right, so Gavin doesn't need to feel bad because he was not the only one who missed it. In fact, nobody got it. Does it make sense now? All right, don't let the decimals throw you off. Just work through them. We know decimals well enough now. For redemption number 5, Gavin, not that you're the only one in need of redemption, obviously, but what did you get?
Negative 3 over 1.
Okay, let's take a look at this one. Again, as we go to set up our slope, we need the y2 minus y1 over x2 minus x1. What did we plug in for our first y value?
4.
Minus?
2.
Ooh, it's not a 2.
Negative 2.
Negative 2. Over, if you start with a 4, you have to start with the?
Negative 1.
Minus?
3.
All right, now here we've got back-to-back negative. Negative, negative gives us, which makes this a 6. Here I've got a negative 1, negative 3 gives us,
Negative 4.
and let's reduce it down and pull the negative out front to get
3 over, negative 3 over 2.
good, negative 3 halves should have been our slope there. How many had that for number 5? Okay, good. All right, and then number 6, third tries the charm. Here we go, Gavin. What did you get? What do we get for number 6?
Negative 2/5.
Negative 2/5 is correct. Questions on these? All right, Gavin, obviously missed yesterday the opportunity to work on this. We worked on just a couple just now, including one crazy one with decimals. Questions on finding slope. Do you need any more practice before we take this quiz, or do you feel like you've got it now? All right, the rest of you feel good to go on finding slope. Any questions at all? All right, clear your desk except for one clean sheet of paper, a pencil, and a straight edge. One clean sheet of paper, a pencil, and a straight edge. Do not write on the paper. The paper is going to be for a cover sheet. You're going to take the quiz on my paper, very similar to what we did last time. We'll take the quiz on my quiz copy. And typically that's what we will do if there's ever graphing involved, rather than you having to provide your own graph paper for the quiz. I'll provide the graph grid already set up for you. The nice thing about that is you know that the graph has to fit on the graph grid I give you, which is a very nice feature. Give you a little bit of an advantage there. So just a sheet of paper, straight edge, and pencil on your desk. Waiting for Brecken. Waiting for teacher. All right, first and last name at the top of your quiz, along with today's date, which is 2/17? Yes, 2/17/21. 2/17/21 today's date. First and last name, 2/17/21 today's date. Numbers 1 through 8. Just some completion questions. Notice number 2, 2 answers that need to be in the right order. Pretty straightforward. Don't miss those. All right, number 9 and number 10, I've given you a couple points in each case. Find the slope of the line that passes through those points. And then for numbers 11 and 12, you're going to use the intercept method to graph those lines. Make sure you mark and label the axes so you don't lose easy points. All right, you may begin. using your cover sheet to cover the top portion of your paper. Just another minute or two to be finishing up. We'll go ahead and take a look at these quizzes tomorrow. For now, if you would, go and take your homework out and turn your textbooks to page 109. Page 109. I want to continue looking at what we began talking about yesterday. That is slope-intercept form of an equation. Our third and really most efficient way to graph any linear equation. The intercept method has its drawbacks. Not many of them, but they are there. The table method has several drawbacks. It's highly inefficient. I generally hate it. So I teach it out of necessity because you have to know the basic idea of how and why graphing works, but I don't like using it at all. This method is the one that works all the time pretty much. It's going to work great. Now that said, there may be occasional times where the intercept method may be quicker and easier still, but this method works great. Want to make sure we're good to go with that. The key to understanding slope-intercept form is knowing what slope-intercept form is. Class, you see it there on the poster in red. What is slope-intercept form of an equation? Y equals mx plus b. Remember when we talk about form, we talk about the way something looks. For instance, Maddie, you played volleyball, right? We talk about serving form. Wham is horrible serving form, right? For an underhand serve, right? Shooting form, Noah. Is horrible shooting form for basketball, right? Okay? We understand form means the way something looks. The form here is the way the equation looks. It should look like this, with a y by itself, an equal sign, something with an x, even if it's an understood one, by the way, and then some other constant term at the end that will be our y-intercept. Okay? That's the way it should look. Students every year get confused. Formula, like m equals y2 minus y1 over x2 minus x1 is a formula. It's something you use to find something, right? For instance, the coach is coming up with a formula to win. All right, so if I put Noah on the bench and I put Brecken at point guard, what does that do for our chances of winning? Versus, well, if we put Noah down low and we put Brecken at shooting guard, no, that won't work either. What if we put them both on the bench and just forfeit the game? Okay, whatever. The formula, I'm just kidding. The formula, I think I'm kidding. The formula is what you strategize. It's a way of finding an answer, right? That's m equals y2 minus y1 over x2 minus x1. That's finding something. That's finding slope. This is the way something looks. And with all three of these equations you had for homework last night, number 6, number 7, number 8 from page 109, they were in this form. You have y by itself. You have an equal sign. You've got an x term, and you have a constant term at the end. The important thing to remember is whatever is with the x class is your slope. And whatever is the constant term class is your y-intercept. Let's try that again. Whatever is with the x class is your slope. And whatever comes at the end, the constant term, is your y-intercept. Because the form again is y equals mx plus b. We already know m is slope. We don't know y, but we know m is slope, okay? And the b we need to just memorize is the y-intercept. By the way, later on in math, you'll learn that lowercase a represents the x-intercept. So it's not totally random, right? You're like, b? Y-intercept? Where'd that come from? Well, you can't use the letter y. Right? That's already in there. You have to use something else. So a and b have been used for x and y intercepts, respectively. So here, we know our slope class is 4/3, and we know our y-intercept is positive 2. The question is, which do we do first? What do we graph first? Well, slope is literally what over what class? Rise over run. But in order to rise somehow or run something, there has to be a starting point, correct? We establish the starting point by first plotting our y-intercept. So the first thing we should have done in number 6 was to plot our y-intercept class at positive 2. So we come up here to positive 2, plot our y-intercept there. Then from there, class, we should rise 4 and run 3. So we're going to start at our starting point, which is the positive 2 y-intercept, then 1, 2, 3, 4 rise, don't put a dot there yet, run forward positive 3, 1, 2, 3, that's where the dot goes, and when we connect the dots, we should have had a line for number 6 that looked like this. Now, you didn't get a chance to do a whole lot of these on your own, so if you didn't get it, it's okay, learn from it, but how many did get this for equation number 6? All right, just Brecken, the rest of you, do we see now what we should have been doing on the homework? And if we missed it, that's okay, as long as we learn from it. Let's take a look at the next one then. Do this with me, correct? You can use the same graph grid you already had, okay? For this next one, y equals negative 5x negative 4, what should I do first? Maddie? Good, on the y-axis. This is a y-intercept. So put the negative 4 on the y-axis. That's my y-intercept. Now, here's the problem. Slope is what over what class? Rise over run, right? So slope has to be a fraction. I see no fraction. Let's make this a fraction by putting negative 5 class over 1. Now again, I always apply the negative to the run. It's just for consistency's sake, all right? So if you're watching YouTube like, but you could do it this way too. I know that. I'm a 4.0. I know how many different ways you can do stuff. I teach my students the best, easiest, most memorable way. So that's the reason I teach. We're going to rise how many, class? 5, but we're going to run negative 1, okay? So we're going to rise 5, 1, 2, 3, 4, 5, and then run backward 1. Again, don't put the dot at the end of the rise. Make sure you rise and run before you put the dot, and then go ahead and connect those dots if you didn't already have this. That said, did anyone already have this? All right, Brecken again got it. The rest of you, is it beginning to make sense as you go ahead and graph the line now? Give you a moment to finish reworking that one. Now, the next one's a little bit obnoxious, but stay with me, okay? Focus here. What do I start with, the slope or the y-intercept, Gavin? The y-intercept. What is the y-intercept, Noah? Positive 1/2. Positive a half is going to be right there, correct? Above the axis, but below the 1, right in between, right? Now, once I've plotted the intercept, Gavin, then I need to do the rise and run, right? So I'm going to rise how much, Gavin? 3. Now watch. I'm at a half. So when I rise 1 class, I'm at 1.5. 2, is it 2.5? 3, I'm up at 3.5. Do we see that? So rise from wherever you are. 1, 2, 3. And then from here, class, we need to run 5 backward, right? -5. So I'm right here. 1, 2, 3, 4. Do you notice that the 5 is still in between the 3 and the 4? And go ahead and connect those dots, and that's what we should have had here. So even with fractions, again, slope being a fraction is not a problem. We're good with that. Even if the y-intercept is a fraction, as long as you're consistent as you measure up and down, you can easily graph fractions this way. Did anyone get that? Brecken, for instance, good. Okay, and the rest of you, does it make sense to you now? All right, set up a new graph grid on your paper and do numbers 9 through 11. They're on page 109. Go and do numbers 9 through 11. Do them all on the same graph grid. You don't even need to write anything on paper. Just look at them in the book. Figure out what things should be. If you need to make little marks in your book, that's fine. Graph them on a graph grid. A Cartesian plane. It should take about 30 seconds or so for each equation once you get that graph grid set up. So very quick, easy method. No math required. Can you beat it? Big fan of no math. Check number 9 once you have it done. Number 10 is in yellow, so 9 is white. 10 is yellow. And number 11 is a white dashed line. Notice all of them have positive slopes, so all of them appear to go upward at different rates. Maddie, do you have all 3 lines correct? Excellent. Brecken? Good to go, good. You happen to know it finishing, that's fine. I say draw your lines just a little bit longer. brackets that we kind of go up near the top of the graph, near the bottom, or near the ends. Okay, so rather than stopping midway through the graph, go ahead and fill the graph a little bit more. You haven't finished with all three? Again, number 9 is the white nearly vertical line, yellow line is number 10, and then the dotted line is number 11. All right, good to go. And Noah. Something looks a little bit off. Let's see what the problem is. Is this number 9? Okay, we don't start at the origin. We start at -1/2 on the y-axis. So start with the y-intercept. From there, 1, 2, 3, 4, 5, and then there's a run of 1. And those are the points we would connect. The rest of you go on to 12 through 15. So do number 10, ignore what's on the chalkboard. Do numbers 12 through 15 there at your seats. Okay, so just plot the y-intercept there at. Good, now from there, now the slope. We're going to rise from that point and then run and connect those dots. All right, last one for this. We're going to start at what y-intercept? Put it out there. There you go. From here now we're going to rise and run understood 1. There we go. Did you see how quick and easy this should be? All right, so the first point is always the y-intercept, and then from there rise and run. Another graph grid, 4 equations this time. work. Solid white is 12, dotted white 13, solid yellow 14, dotted yellow 15. Gavin says he got them all. And did you get them all? Good. Breckin, which one are you looking funny at? Okay.
Put it on -3. I think it was.
Oh, I see what you did. You combined number 12 and number 15 together. And that's why you have these two parallels, because you have the same slope, the same slant to them. All right, Noah, how'd you do this time?
I don't know.
All four of your lines look exactly like all four of mine? I think so too. Excellent, excellent. All right, questions on slope-intercept form? Isn't it neat to just like look at the equation and draw the line and not have to do any math? Isn't that nice? Yeah. Okay, so this is why I like slope-intercept form. Here's the only problem. If you look here, not all the equations start out in slope-intercept form. Sometimes you have to get slope-intercept form. But here's the deal. Really, to get slope-intercept form, all you're doing is getting y by itself, right? Like here, the 3x moves over as a negative, so that we initially get 4y equals, move the 3x over, negative 3x, negative 16. And then everything can be divided by 4, right? You can divide both sides by 4, but that's no different than dividing every individual term by 4, giving us the negative 3/4 x minus 4. So I don't know that it's hard to get slope-intercept form, but once you get it, negative 4, rise 3, run backward 4, draw the line, as you see there. Does that make sense? So getting slope-intercept form, I suppose, is the key, but just get y by itself. Just make sure the x goes in front. When you move the x, it has to drop in front of the constant. Does that make sense? Let's practice this now together. Write this equation on your paper. 3x positive 2y is equal to 6. Now, to be fair, the intercept method would be really quick and easy here. It would be, right? 2, 0, 0, 3. Boom. I mean, so the intercept method would be super easy here. Let's show, though, how to get this into slope-intercept form. Again, the point is you'll have options now. But to get it into slope-intercept form, the real key, class, is to get the y by itself. Let's start by moving out the 3x as a negative. To get 2y equals, nope, put the x before the constant. There we go. Just make sure when you move it over, you put it before the constant, so we'll end up with y equals mx plus b. Does that make sense? And now, instead of dividing both sides by 2, we'll do the equivalent, which is divide every individual term by 2. And when we divide everything by 2, what does the equation look like now? Gavin?
Y equals negative 3 over 2x positive 3.
There we go. You simplify down. And now, if I were to graph this, class, I'd put my y-intercept at 3. I would rise and run. And there's my equation. Okay, so get the y by itself. Make sure you have that y equals mx plus b form. Plot, rise, run, connect the dots. Super easy. You're in your textbooks there. Set up one more graph grid. And I want you to do page 109. Let's do these one at a time now. Number 21. Go and do number 21. We're going to do several on the same graph grid. So take a moment, set up the graph grid, then manipulate 21 to get it into the slope-intercept form we want, that y equals mx plus b format. Once you've got it, plot the y-intercept, rise and run, connect the dots. At least this time it didn't fly off the board and hit me in the head. Blood everywhere. Okay, that hasn't happened yet, but you know, it's one of those things nightmares are made of. Being attacked by a rogue graph grid. Now here we've got just a little bit of an issue here, class. The y is negative. So if I move the 4x over as a negative, to get negative y equals negative 4x positive 12, how do I get rid of this? Divide everything by a negative, right? Or essentially change all the signs. What's another option? What if we didn't want to have to do that? What's another way to get the y by itself? Kind of unconventional, but...
negative y in the 12.
Yeah, kind of pull a double switch. We've got a couple options here. If we double switch these, then the 12 comes over as a negative, and the y's over there as a positive. And notice we have y equals mx plus b. It's just kind of backwardsy. Okay? So this method is a little bit more straightforward, because it puts in y equals mx plus b. This way is mx plus b equals y, but the point is we can still see the slope and the y-intercept. And oh my, what's our y-intercept, class? Negative 12. Something like this down here. Doesn't fit on my graph grid too well. From here we would have to rise, class, 4 and run positive 1. And we get a line that looks something like that. Questions on that? Does it make sense now? You see what to do with a negative y. Just divide the negative away, or really just change all the signs. Let's do 24 next. Let's do 24 next. So much more straightforward. Almost too straightforward. Let's finish this one out before we wrap up. My clock is wrong. What do I do to get y by itself? Put the x over as a, to get y equals negative x, positive 3. I can clearly see the y-intercept, class. 3, right? But what's the slope? Negative 1 over 1, right? So if you don't see a number there, it's a 1 over 1. So class, from the 3, I'm going to rise 1 and run negative 1 and connect those dots. And there's my line. All right, questions on that one? We're going to practice more with this tomorrow, practicing getting equations into the slope-intercept form and then graphing them from there. There is no homework this evening. However, I think I will give you a couple extra credit problems. How about that? Okay, so I'll give you 2 shots at extra credit. Page 109, number 26, and number 31. Number 26 and number 31. You can do them both on the same grid. You can do just one if you want. You don't have to do either of them. We're going to start by looking at those after we go over the quiz tomorrow. All right, have a wonderful rest of your day, and you are dismissed.